Okay, this is awesome. So who are you?
Hi, I'm Tom Bewley at the University of California, San Diego. We're the coordinator of the Robotics Lab, and we're developing these Mobile Inverted Pendula. So this is a educational kit that each student can buy this kit, $150, and can build up from scratch and learn how to do embedded control and robotics.
For how much?
It's about $150.
Yeah.
We did a prototype run last quarter, had about 100 students run on this, and we're going to be coming to market with the kit soon. So this is the BeagleMiP Black at the core of this thing, which is a TI product. It's called the BeagleMiP Black.
This enable this?
Yes, and so this is the engine that runs this thing. It runs Linux, and you program in C, and you can program at a low level. You can control motors, read encoders. There's on the breakout board that we developed at UCSD, there's a battery controller, the H bridges to drive the motors, and a bunch of connectors. So essentially everything that you need to drive this. And it's designed for general purpose robotics, and so you can use it in little inverted pendulum guys, you can put it in quad rotors, you can put four-wheel steering cars, so we're going to be coming to market with a few different SKUs.
It's like magic.
It's a lot of fun, yeah, controls is like magic.
I mean, this is... what have you done before? What were you doing?
So we are a dynamics and control shop, and so what we do is we figure out ways to analyze dynamical systems and build simple systems that can overcome complex obstacles. So for instance, small vehicles with just a few motors that can climb stairs, internally propelled spheres, hopping devices. So we've looked at a bunch of different devices. We've been working with the toy industry to come to market, so a version of this we've developed in partnership with WowWee, and it's called the MiP, and it will be coming initially at Best Buy in May, broadly available shortly thereafter. That's going to be a banner toy for WowWee this year, and we've been working closely with them on the dynamics control that really makes it all work.
How does it work?
So,
what kind of software do you need to run on this? This is an ARM processor, right?
So, yes, so this is the Cetera processor inside the BeagleMiP Black. This is the connector board. There's an IMU, so it has accelerometers and gyros. It also has a magnetometer. We're not using it at the moment. There are encoders on the back of the wheels, and so each wheel we can tell how much it turns. So with a combination of the encoders and the accelerometers and gyros, we can get attitude information of what the vehicle, what orientation the vehicle is in. And then in addition to that, of course, we have individual motor controllers, and so we can balance, and so it's just the magic of feedback that gives it the life, the same thing that keeps you and I from falling over as we get disturbed and move around. The nice thing I like about it as a toy is it's organic. You give it a push, and it has to respond in the same sort of way that a human has to respond. And so that's what makes it the fun placement, and also engaging as an educational environment.
And what's also absolutely crazy awesome about this is that it can carry more stuff.
Yes, and so the version that we're coming to market with through WowWee actually has a tray, and it has enough payload capability that you can put one on top of another. You probably had a video of that you took this on.
But for education, students can add more sensors, cameras.
That's entirely the point. So this is a very compelling reference design that you can move into, and you can learn how to do all of this from the ground up. And so you can learn how to drive motors, you can learn how to read encoders, you can learn how to read accelerometers and gyros. And so everything that you need to do in order to build whatever robotic design that you're interested in. And this is a starting vehicle. And then the idea from here is that you can 3D print your own shells. You can put a dinosaur shell around it, or whatever your imagination takes you. You want to put a couple of guns on it. I actually hacked up one of the production MIPs to put a little bubble making machine on it, just because I thought it would be fun. So the idea of all of this is to empower the person who gets it to take it apart and extend it and get creative. And I think really one of the things that's going to turn robotics on its head is 3D printing. And so you're inspired, you fire up some 3D CAD program, and then you just go crazy and let your imagination go wild. And that's what we want to enable with technology.
Oh, you can also just use gaffer tape and some tissues from your mother and stuff.
Yeah. So
like all kinds of stuff, right?
Absolutely.
But also, what kind of sensor, what kind of how do you connect the sensor here? How do you connect the camera? Where do you connect it? If you want a camera.
Let me introduce James. James would like to jump in here and he can say a little bit about cameras.
Hi.
What do you do?
So, I am the designer of this board. I use this for educational purposes to design robotics control systems. So this allows us, through the power of Linux, to combine all of the sensors that we need in a robotics laboratory, including cameras. So instead of worrying about embedded drivers for specific camera applications, we use the abundance of Linux drivers to attach any webcam that you wish for your specific application.
Any webcam?
Any webcam with Linux drivers, which is 95% of webcams on the market.
What else?
So, as a robotics platform, we wanted to make the process of designing a robot much simpler than even the Arduino platform.
It's simpler than Arduino.
For hardware development. So instead of designing your own circuits using breadboards and Eagle, we have designed built-in connectors for many of the most common sensors that you would use on a robot. So everybody likes to use PWM to drive motors.
What is that?
Pulse width modulation is a technique that allows us to fine-tune the amount of power going to a motor, so we can have the fine control necessary to do balancing.
So that's already in there, right?
Yes, so this is enabled in the hardware of the Citara processor that powers the BeagleBone Black. But only through our CAPE, which is a daughter board on top of the BeagleBone Black, are we able to allow users to simply plug a motor directly into our board and have power and encoder information through the same plug. So the user doesn't need to use a breadboard or design their own circuits. They simply plug their motor and encoder in and off you go. You can start developing software.
It looks like there's a bunch of other ports.
Indeed.
What do they do?
So, we also have 6 outputs which can control hobby servos or brushless speed controllers.
Hobby what?
Hobby servos.
What is that?
So, what we are able to do using hobby servos is have a self-contained black box which controls its own position using a feedback controller. It draws power from our board and also a signal from our board so that the user calls a single line of C code in order to set the position of a servo's output shaft to control a motor arm or any other number of robotics applications.
Can I also jump in?
Yeah.
There's one other thing I wanted to, you asked what else can you connect it to?
Yeah.
One thing that you can connect it to is an infrared sensor. This is from GestureSense, one of our partners here. So the commercial version of the Mobile Inverted Pendulum actually has one of these embedded in the front, and so it can detect various different gestures. It's embedded in here. It just has a transmitter, 2 transmitters and a receiver, and so it can tell how your hand is moving, and so you can get information to the vehicle just with hands. Doesn't require a Bluetooth device.
How far do you go?
And so, well, to answer that question, I'd like to show, have Michael step up here. Michael Kosick is the CEO and founder of GestureSense, which builds devices like this, and so I'll let you pick it up.
So what kind of devices do you do?
So we actually provide our sensors and our positioning software that goes on a chip to a variety of OEMs. So in this case, we have a partnership here with the UCSD and WowWee Robotics for their toy product in MiP. That's the MiP.
This is awesome. Yeah.
You've seen them at the show.
So it's in here.
It's in here. Yeah, those are the sensors. So yeah. You'll see it's a very similar configuration there.
Nice. 2 eyes. You need two.
Yes, you need 2.
Yeah.
So with 1 transmitter, 1 receiver, you're going to get a range, which fundamentally is what our technology does. And we have a gesture engine on top of that. But with 2 transmitters and a receiver, you're going to get 2 ranges, allowing you to do differentials, allowing really interesting gameplay, including gesture control, but also including tracking of objects and other things which you'll see in the future. So,
Do you do also other sensors?
we predominantly focus on positioning and gesture sensors.
Do you have like different categories of gesture sensors? Do you have like more advanced ones too?
Well, yes, absolutely. We have array-based ones, so you'll see some of our stuff coming in automotive, so you can get a direct user interface, so that's kind of like the Kinect, but for everything.
So you can do like a student can connect a different sensor if they want. They can connect more stuff. They can connect.
That's the beautiful thing about this. This is a platform,
Yeah.
right? And what these sensor modules will allow us to do is, or them to do rather, is connect and choose the components that they want, add it to the platform to add that type of control.
So you don't need to speak to your robot. You just wave to it, right?
That's definitely a way to see it. But
So for now, the one included in the commercial one is close by, but you could have one further away. You can have different.
absolutely, and the same. So our markets vary, not just robotics, but lighting, digital signage, automotive, all sorts of consumer electronics accessories.
Yeah. Do you promise to provide all your sensors to this project? They can use all of them, like as many they want, all the students?
Absolutely.
We're actually working together with Michael to probably distribute through SparkFun. We are initially going to be making this kit available, and eventually these other kits using the same BeagleBone and our same breakout board with the GestureSense technology for sensors that you can mount to do gestures. You can also mount them on the base of the vehicle, so as the vehicle approaches an edge, you don't want it to fall over. You can have the sensor check that, and so you can use these for a variety of purposes. So we're going to be providing a kit where you can build and learn and explore how to do embedded control and robotics, and we will also be figuring out how to come to market. Michael will be coming to market with these that you can buy as individual units.
So which other sensors would you like to see?
So the purpose is to make the user experience as easy as possible to get students interested in embedded programming and robotics. So we provide an open source library that allows the user to plug one of these gesture sensors directly into this port and not just power the sensor, but read raw data and gestures through our open library. You can also directly plug in commercially available GPS systems into this port and commercially available long-range radio systems into the top port. All of these are supported using the open library, so the user can start programming their robot without having to learn the back-end low-level communications necessary.
Long-range radio.
Yes.
So could you have one of these just go away and come back later?
Yes. So we have a half-mile range to both control and stream video back from our long-range robots.
Could you also, like, for example, with a smartphone, take a picture of the room and it learns and it knows where to go and stuff like that?
So this is on our roadmap, is robots that are aware of their environments. So thanks to a process called structure from motion, we are able to mount a camera to either of these robots, and as the robot navigates through a room or around a building in the outdoors, it will continuously generate a three-dimensional model of their environment.
And you should also listen and recognize voices and know where the child is to go back and play with the child and stuff like that?
So one of our other researchers at the University of California, San Diego, is developing an array of microphones which mounts to the top of this device, and using phase delay recognition between the multiple microphones can very accurately determine the direction from which a user calls it. So not only will it recognize a word that you say, but it knows exactly the direction that it came from, so it can turn to you and come toward the user.
And this is you can add it to this one.
Exactly. So that's one of many hackable additions that can be bolted directly to the top of this balancing robot. A user can either directly bolt the gesture recognition system to the top or the multiple microphone array.
So what's on the back?
Yeah. So on the back we have a 2-cell lithium-ion battery which provides 12 hours of battery life to the BeagleBone or 6 hours of balancing life. It is protected using a lithium secondary protection circuit and cell balancer. All of the charge management is built into this board, so the user doesn't need a separate charger. You simply plug in a very standard 12-volt power supply that's available at Radio Shack and Best Buy, and the entire board will maintain and charge the battery itself.
Is there any way that someone buying this one can do something too? Isn't there a port here too?
So soon from SparkFun, you'll be able to buy hacker kits that allow you to add backpacks to the back of this toy, and through a serial connection, a user can program new dance moves and new performance characteristics into the product.
But that backpack doesn't have as many ports as the student kit, right?
No, so this will be a hacker kit, whereas this is an entire robotics platform. The idea is that whether you want to create a flying drone or a rover that can be driven through Wi-Fi, everything that you need is built into this one robotics platform. So you don't need to be a hardware developer to begin designing robots.
So TI's ARM processor here is fast enough to do all this, fast enough for the robot not to fall,
Yes.
which is impressive.
Very much so. So this is a 1 gigahertz ARM processor which is running a full distribution of Linux. This allows users to develop in a Linux environment using many programming languages such as Python, C or JavaScript. So we are openly available to all computer science and mechanical engineering students.
And you're probably also working on a big one, right?
Yes.
How big? Can you make
Regarding the multi-rotors,
regarding balancing?
regarding these.
Is that secret?
No?
Don't you have a kid-sized one?
So what we have in our lab is many years ago we designed a product called iFling, which will roll around on the floor while balancing and actually pick up ping pong balls using an intricate mechanism, collect the ping pong balls, and then lay down and fling the ball across the room based on what it's picked up from the floor.
So what do you think about the future of robotics? What's going to happen? Are we going to have, is everybody going to have robots in the next 5 years? What's happening?
I think the future of robotics is going to be focused on the high school and university markets. I think we need to start pushing STEM more and more in the university area, such that students will begin learning embedded programming from a much younger age. And this is what's going to accelerate both the embedded control area and also the robotics field further and farther in time.
And Google is doing something. What are they doing?
Google's doing many things, but they keep it under their belt.
The one they bought, Boston Dynamics, this is basically what you're doing.
I'm not too familiar with what Boston Dynamics is.
But it's, there was this dog on YouTube where they're pushing it, it stays standing.
Oh,
nearly...
yes. Big Dog, I remember seeing that. So, every university has their own take on robotics. What we do at the University of California in San Diego is what we call low-cost robotics. So we want to make these platforms available to students, such that every student in the class is able to have their own platform and be attached to their platform, such that they enjoy the process of designing software for robotics.
What can the quadcopter do?
So the quadcopter can either be flown for fun, or what I use it for.
Can you
Feel free to pick it up.
Yeah.
So we use this platform for creating 3D models of structures outside, in particular archaeological dig sites in Italy and Jordan. So we use a process called cyber archaeology, where instead of disturbing an archaeological dig site, we collect digital data using aerial imaging platforms and then construct a three-dimensional model of the archaeological dig site, which we can then analyze back in California.
And what's it called? You have all this technology to when there's wind, GPS, kind of like autonomous kind of stuff a little bit.
Indeed. So using a downward-facing camera and a technique called optical flow, the quadrotor is able to stay in place in the air, since it has an idea not only of where it is in space, but where it is relative to the user. So not only is it very easy to fly compared with hobbyist helicopters, but it also packs on board the power of the Linux board, such that we can do onboard computations and data acquisition.
Is there a price for that one?
This entire unit is roughly $350. These little units will be about $150.
And none of them selling yet, right?
None of them are selling yet.
How soon?
6 months.
Within 6 months.
6 months.
At CES 2014, and who are you?
My name is Samuel Stavari. I'm a PhD candidate at UC San Diego.
So what do you do?
So I specialize in controls and dynamics. Basically, I work in the robotics field, designing all sorts of Segway-like technologies. Basically, coming up with novel, interesting ways.
So this is like self-balancing home robot.
Right. It's also got hand gesture technology in it, so you can see right here. This guy's a little bit low on the battery at the moment, but he's able to react to my hands like you saw just now. He also can dance. Along with all the other capabilities.
Whoa.
Really powerful balancing capability. So I'll go ahead and get a MiP on here.
Whoa.
Now I'm hooked up to the Bluetooth app, so I'm going to go ahead and control that guy while he's holding the other one. And I'm able to control via the app. The app is available for iOS, and we'll have the Android app available soon, probably about a couple months out. This is going to be shipping in spring this year.
Whoa. This is awesome.
We're looking at $99 price point as well.
Really?
Yeah.
And you get your own Segway.
Yeah, you get your own Segway, exactly.
Is it Segway technology?
No, it's similar to the Segway technology. It's academic-wise, it's called the Mobile Inverted Pendulum problem. And so it uses basically uses an IMU encoders to balance itself similar to a way a human tries to balance a broom or a pen on their hand.
Nice. It's like this at CES in Japan, this Honda where you sit on the thing and balance.
Mm-hmm. Yes, it's very similar. It's the exact specific controls is slightly different, but in general the concepts are very similar to that.
So what's it called? Does it work because the top of it is very light, or nothing to do with that?
It depends. It'll change depending on where you put the center of mass. Performance capabilities actually change. For Segway, the higher the weight goes, the more stable you can normally do it. The advantage of bringing the weight down is you can do self-uprighting maneuvers, be able to get it to stand up on its own.
Why is this one a little bit like, it looks like it's shaking a little bit?
That's because
I think
of
he's
battery
low on
performance.
battery.
Yeah,
It's battery.
Yeah, depending on battery levels, the amount of the microcontroller has no actual knowledge of the battery voltage. So as battery performance drops, the controls still think it has the same amount of motor power, even though it doesn't, and that's why you see that sort of jitteriness in it.
That's really awesome. So, what's the next thing?
The next thing, that would be something to ask them.
I mean, the future robots, everybody's going to have robots at home, no?
Yes.
What do you think?
I mean, everyone is going to have robots, and it's kind of a question of, what people are hoping to see. I mean, you can have personal robots helping out where you need, more sort of consumer and robots. The big thing is, being able to interact with your robots, having kids interact, having robots help out humans, do medial tasks,
So I'd like to have this robot carry my bag, and just follow me around.
Yeah, it's
It's a little bit too much weight. I'd like it, but the big one just might be able to do that.
You might be able to make a big one that does that?
40-incher in the pipeline right now.
all right. I wasn't sure if I'm allowed to talk about it, so that's why I don't want to say it. But yeah, we do have a 40-inch one designed to eventually carry groceries. Help people depending on whatever you need to carry if you don't have enough hands.
For real?
Yes, for real.
For real? It's WowWee.
Yes, yeah. It'll be produced.
Are you the CEO?
No.
No? So WowWee is like been showing off the 2, 3, 4 CESs, like awesome.
I think 8 or 9 CESs in
8
a
or
row.
9?
Yeah, we've been a long-term supporter of CES. We love it. We've launched a lot of our products at CES. We've been in robotics for 10, 15 years.
Always robots. WowWee's robots.
A lot of robots. One of our flagship famous robots is RoboSapien. Very recognizable. We'll have some over here tomorrow, so swing by real quick. You can grab a shot. We have a new designed version of RoboSapien X for the 10-year anniversary.
Are you the leading robot maker in the world?
We're one of the best.
I mean, who's selling more robots than WowWee?
We're one of the leading.
One of the leading.
Yeah.
So,
especially in commercial robots, I mean, we're really combining robot in a toy kind of fashion, so we're definitely a leader on that front.
nice. What do you think Google's doing with robots? Because there's the Android guy supposedly is doing something.
I don't know. I've been reading about everything that Google's been, buying up all these robotic companies. I'm really not sure what they're planning on.
Does it sound interesting?
I can't speak to it. I imagine, you know, they just bought Boston Dynamics, so they have quite a bit of capabilities now. Depending, you know, Boston Dynamics has produced some amazing robots that have.
What do you think about those Boston Dynamics ones?
Sorry?
What do you think about those? Have you seen them for real or only on YouTube?
No, I've only seen them through YouTube. I've never seen any of the specific Boston Dynamics, but I've seen other military robots that have done, and it's amazing what robots can do nowadays, from running faster than humans to being able to, you know, pick up things that most humans can't pick up.
And also, what's important is the whole emotional aspect of, like, if people are going to accept it or not, right?
Yeah, and there's a lot of, I know a lot of different universities. There's the Xeno robot that's spent a lot of time trying to help interaction, you know, kind of bring interaction of robots with humans. And one of the big things, the reasons why we're a huge fan of MiP, is that it's much more human-like as a toy compared to all these other toy RC vehicles and that sort of stuff you get. It allows for, you know, a kid to be able to interact with the toy, not just kind of be like, oh mom, look, I have a vehicle that I can drive around with an iPhone, but, you know, it's sitting there, it'll dance for you. You know, it's a great source of entertainment.
Awesome. So the future of robots. It's gonna be cool.
Yeah. Oh, yeah. The future. There's the future of robots is really growing quickly, and you know it'll be amazing to see what comes up next.
What do you think is the coolest robot on the planet right now? Is it the Honda one, or is it the Now, or
The
something totally
coolest
different?
one, I mean, from that's of course it's MiP. I mean, MIP's one of the first.
That's pretty
It's
awesome.
the first Segway-like
$99.
technology that's, you know, brought to the side to allow kids to really experience, you know, the amazing technology that goes to get something like this done.
Awesome. So you can buy two and three. And
You can buy as many. Third one's very close to being done. Yeah.
You can add the Coke and it'll just carry anything.
Yeah, definitely. It'll carry anything, and you can even give it a shove while it's, you know, balancing something.
It's like Boston Dynamics. I know. Sorry, that was a bad.
The Boston Dynamics robots are a bit bigger.
Yeah.
But yeah.
So along
You can push it and it's fine.
we also got racing.
It's so awesome.
Or you can shove him, he's pretty durable.
Yeah.
Dance to the beat of music. And then
What are you going to input now?
Let's see. Well, let's see. I have to go back. There's a track mode. And we go left. Let's go right. And let's go forward.
He's not wanting to balance it
I've been told you can do up to 100 commands sequentially.
That's insane.
Every so often there's just one.
Is it not rating for my commands?
I don't know. You might have to change the mode and change the back. So let's see. Do that and then back.
Always because
Now he's ready for commands to be input. So you do. You should.
What is it thinking?
Sometimes you see little commands. Try that again. Let's see.
picking all the winners. Very nice.
There we go. Wheels are engaged. Oh my god, this guy's going rogue. This one might not be trustworthy with your drink.
Okay. And then there'll be. Not too much.
Let's see. There we go. There you have it.
This is fun too. So we say that he moderated to his own weight.
Whoa.
Trees a little constantly sliding right now.
Yes, I did.
Do take a beating.
Nice. That's too much.
And you're based on